Hi, friends, very good morning. And today we are discussing an interesting topic that's magnetic force. In the previous class, we had learned what's Lorentz force, and we know it's a sum of electric force as well as magnetic force. Okay, so there we had derived this equation for this magnetic force. Okay, so what's magnetic force? Magnetic force F that is equal to Q into V cross B. That is Q it is charge, then V it is velocity of the charge, and B that is the magnetic field. Okay, so when a charge Q enters a region where there is magnetic field with a velocity V in a direction perpendicular to the direction of the magnetic field, then we get this magnetic force experienced by the charge equal to Q into V cross B. Then what is V cross B? V cross B means cross product of V vector and B vector. That is magnitude of V into magnitude of B into sine of the angle between the V and B. Okay. So in this case, this charge is entering perpendicular to that of the direction of B. So it is sine 90. What's the value of sine 90? That is 1. So it is V into B simply. Okay. So F magnetic, that is magnetic force equal to Q into V cross B, that is QVB. Okay. Now we are going to derive the magnetic force acting on a conductor, acting on a current carrying conductor, current carrying conductor. Okay, so here we have a current carrying conductor, and we know that there will be magnetic field lines around it. Okay, so what will be the magnetic force acting on this current carrying conductor? That's what we are going to derive. So magnetic force, we know that the equation to find magnetic force that is equal to Q into V cross B. Okay. Now we are going to find the magnetic force on this current carrying conductor. This is the magnetic force acting on a charge Q. Now we are going to find what? The magnetic force acting on a current carrying conductor. For charge Q it is Q into V cross B. So a current I that is passing through this straight conductor. So, suppose there are n electrons. Here we have a conductor. It's an enlarged view of that conductor, and it has this area of cross section that is A. Then it has a length L and a current I is passing. Then, so current is, what is current? It's a flow of electrons. So let the number density of that electrons be n. Okay, number density means total number of carriers. Here it is electrons. So number of electrons divided by what? Divided by volume, that is number density. So here n equal to number of electrons divided by V equal to area into length, A into L. Okay, so what will be n? N will be total number of electrons, that will be, here it is electrons, mate any carrier. So n equal to NaL. Okay, so for one charge Q, it is magnetic force is F equal to Q into V cross B. So here N charge, total N charge is flowing. So it will be N into AL into Q V cross B, is it? Since it is for one charge, for N charge, NaL into Q into V cross B it is. Okay, so F equal to NaL into Q into V cross B. So what will be the V here? Here, each charge is drifting with a velocity Vd. So here the velocity is drifting velocity of drifting into Vd cross B. Okay? Yes. Now, F that is equal to N into A into L into Q into Vd cross B it is. Now we have to look at these values. N, Q and Vd. NQVD that is equal to J, that is the current density. Okay. So instead of NQVD, we can write F that is equal to J into, then what remains? NQVD. Instead of that, we wrote J. Okay. So NQVD it is J. Then A and L remains. A, L into VD cross B. Then one more thing you should remember. This current density J that is equal to I by A. So what will be J into A? J into A equal to I, is it? J into A that is equal to I. So we can replace it by I. So F equal to I. Then yes, one more thing. This QVD that already we had done that. So what remains? This L cross B remains. Okay. So what we get, because we took NQVD that is equal to J. Okay. So NQVD that is equal to J. Then we replace it with J. Then what remains? Then remains A and L. Okay. So A into JA it terms I. J into A equal to I. So what remains? IL cross B. Okay. Length IL cross B. So this is the equation to find the magnetic force on a current carrying conductor. Okay. F equal to IL cross B. Okay. So when a charge Q that is entering a magnetic field, what happens? With a velocity v, it experiences a force, and that is what magnetic force. And the equation to find the magnetic force experienced by a charge is F equal to Q into V cross B, and the equation to find the magnetic force acting on a current carrying conductor, that is n charges are flowing through this current carrying conductor, and for that it is I into L cross B. Okay, ILB. So suppose we have a wire. Now we can go through a question. We have a current carrying wire of length 2 meter and a current of 1 ampere is flowing through that wire, and and this wire has a mass of 5 gram. Okay, then it is suspended in air. Then find out the magnetic field. So in that case we can use this equation mg equal to ILB, because here L and B are perpendicular to each other. So IL cross B, ILB sine 90. So sine 90 that is equal to 1. It becomes mg equal to ILB. So B equal to what? Mg by IL. Okay. So we can substitute the values and find out the answer. Okay. Thank you.